10C's, radicals. Let's go backwards today. Just like all processes in math that I can think of, a lot of them, whenever you learn to do something, you can learn to undo it. When you learn to add, well, we learn to subtract. You learn to multiply, we learned to divide. We learned to square a number, we learned to root it. Well, last day we looked at converting an entire radical into a mixed radical. So an entire radical, no coefficient out front, and just some form of a radicand underneath. That's an entire radical. Actually, let's move that over to the entire radical. Mixed radical is when we have a coefficient with a radical that has a radicand value underneath, whatever that value is. Now, each form has a purpose. Less and less applications in real life. There are applications for it, but not as many. You will find next year this mixed form becomes much more useful and beneficial with calculations. We're not going to add, subtract, multiply, or divide with radicals this year. Next year you will, and mixed form will be beneficial. Entire radicals, again, have a purpose, which we will find out about at the end of this short lesson. So, very quickly, from yesterday, how did we turn an entire radical into a mixed radical? Well, if you recall, we talked about taking the radicand and writing it as a multiplication question, but we wanted to make sure that one of the factors that we could split it up into was a perfect square or cube, depending upon the situation. Splitting 18 into 9 times 2 is nice because we could root out the 9, because this, remember, is the same as saying we have root 9 times root 2. This is just my abbreviated way of showing it. And what's the square root of 9? It's 3. So if I can take 18 and write it as 9 times 2, the 9 will root out and become a 3. But we still have, after this 9 gets rooted out, we still have the radicand of 2. So root 18 is the same as 3 root 2. So we multiplied, or kind of divided them to get a multiplication question for something we could root out. And we square rooted to take it out. Well, today we're going from mixed into entire. So today we want to take a mixed and go to an entire radical. So this 3 we don't want out front. We want it to go underneath now. Well, if we think about the fact that we square rooted to take it out, how would I put it back? Well, the exact opposite. I would simply, in order to put it back, I would need to square it. We square rooted the 9 to take it out. So if I want to put the 3 back, I do the opposite, and I'm simply going to square it. But because we still have the radicand underneath, we need to multiply by the radicand that's there. So if I were to do that calculation, 3 squared is 9 times the 2. There's our entire radical, root 18. Root it out, square root it out, so we square it to put it back. That's really all there is going to be to doing these calculations. A mixed to an entire, we square or cube the coefficient. The number out front, to put it back in, we're going to square it or cube it accordingly. But we have to make sure we also multiply this by the radicand value that's already there. So I have 3 square root 4. If I want that 3 to go back under, I need to square it and then multiply by the radicand that's there. 3 squared is 9. 9 times 4. So we end up square root 36. There you go. An entire radical. Here we have 6 root 2. Well, we want this 6 to be back under the radical sign because it's a square root. We're going to square the 6 to put it back underneath and then multiply it by the radicand that's already there. So 6 squared is 36 times the 2. All of that is under the radicand, and 36 times 2 is 72. So 6 root 2 is equivalent to root 72. We can always double check. Note that our calculator, you can try all you want, you can't turn a decimal value into a radical. Calculators can't do that. But we can make sure that we've done it correctly by simply checking that 6 root 2 equals root 72. Let's try that. 6 square root 2 has a value of 8.48, blah, blah, blah. Well, we think that the 6 root 2 is equivalent to the entire radical root 72. And when we do that, we get the same thing. So that confirms that 6 root 2 and root 72 have the same value, a mixed radical and entire radical, different forms of the same thing. Now, the only thing with this third one you have to be careful of is the fact that now we have a cube root. Well, our process is the same, but what am I going to have to do to put the 4 back under? Well, in that case, I'm going to need to cube the 4 before I put it under, and then I have to multiply by the radicand 5 that's already there. Square roots, remember our index is just 2's. That's why we're squaring. But a cube root, we need to cube it to put it back under. 4 cubed is 64 times 5. So 64 times 5 is 320. So we end up with, don't forget, see, and I've already made an error. I don't know if anyone noticed it. It's not square root 320. We need that index 3, and I forgot it there. It's something small, but it's a big difference. You need to make sure you include the appropriate index. So we end up in that case with the value of cube root 320. So that's all there is to it. Whereas entire to mixed, a lot of work with basic facts and some little, the reducing, a little bit more involved, but mixed to entire, pretty straightforward, I hope. Where is it useful though? If we go to page 21, ordering radicals. This is where it can be useful to have an entire radical. Ranking entire radicals. Is what you want to do. Rank entire radicals, not mixed radicals. Because entire radicals, now we're just comparing radicands. So the instructions say order the radicals from least to greatest. Now it says without your calculator. You might need a calculator for support, but there's no way you should have to use a square root or a cube root button on your calculator. First thing we want to do is convert everything to entires. Convert to entire radicals. So I'm going to do the 4 root 3 first. Square root. 4 goes underneath, so it's 4 squared times the 3. 16 times 3 gives us root 48. 3 root 6. Well, 3 root 6. To put the 3 under, I need to square it to put it back under the root sign. Multiply by 6. This gives us 9 times 6, which is 54. 2 root 10. Well, to put the 2 back under, I need to square the 2 and multiply by the radicand that's already there. 2 squared is 4. 4 times 10, we have square root 40. Now, a whole number. We can still put a whole number under a root sign. Right now, there is no root sign. So what would I do to put a 7 under? Well, I would just square it. 7 squared. Square root 49. Simplicity of that throws some students off. Now, once you have everything entire, we rank based on the radicans. By looking, now that they're all the same kind of type of radical, we just want to look at the radicans that are there and rank the originals. So we want least to greatest. Well, what's the smallest? 40 is our smallest radican. So 2 root 10 is the least. Finished. What's next smallest? The root 48. So the 4 root 3. Always rank originals, don't rank your work. Next smallest is 49, which was the 7. And the biggest, root 54, which was the 3 root 6. So entire radicals aren't going to be important moving forward as a mixed radical, but it still has a use. Here, second question, same idea. We want to order the radicals, but now we have cube roots. Steps really don't change. But what do we have to be careful of here? If I'm going to put under a cube root, what do I do to put the 2 under? I need to cube the 2 because it's a cube root. 2 cubed is 8 times 5. We get cube root 40. Cube root 42, fantastic. We don't have to do anything to that. It's just cube root 42. It's already an entire radical. 3 cube root 2, well, we're going to cube root. How does the 3 go under? We cube the 3 and multiply by 2. 3 cubed, 3 times 3 times 3 is 27 times 2. We get cube root 54. And then we have 2 cube root 3. Again, how does a 2 go back under the root in this case? It gets cubed, and we multiply by the 3. That leaves us with cube root. 2 cubed is 8 times 3, which is 24. Now that we have entire radicals, well, now we can rank. Least to greatest again. So which is our smallest radican? The 24. So our least value is 2 cube root 3. The next smallest is a radican of 40. So 2 cube root 5 is our next smallest. Now we're left with the cube root 42. And that obviously leaves the largest radican, the cube root 54, which was 3 cube root 2. And there's the radicals ranked from least to greatest. So a little bit more involved to go from entire to a mixed, but a mixed radical to entire, pretty straightforward process. Today's assignment shouldn't be that long. It's just multiplying. You don't even have to know your basic facts. You just have to understand this little process. As I said at the start, this unit doesn't have great, big, long, multi-step solving. It's little processes. You need to stay on top of them. Make sure you understand entire to mixed. Make sure you do this assignment to understand mixed to entire radicals. Booklet, page 22. Don't forget the key booklet that is posted in the classroom will have solutions and process to help you if you're not sure, and then some textbook pages, and all the answers, of course, are in the back of the textbook. Stay on top of these little processes. They're not really involved, but there's a lot of them. Ingrain it in your brain through practice. Have a great day.